Welcome back to Ox Tools. I'm Tom. So, got a nice tasty batch of meatloaf for you guys. Quite a few things actually. Got some cool books in the mail. Some viewers sent some interesting books in, and some tools. A viewer sent in a special tool to do friction stir welding. So we're going to check that thing out. I haven't tried it yet, so we're going to try setting it up and see if we can make it produce a weld, which will be pretty interesting. I got a really cool antique oiler for the etching press. I did some horse trading with with the young lads, and one of them brought Austin actually, he brought a really neat oiler we're going to check out. I got a monster micrometer, and I got a really cool old picture, an old black and white picture for my birthday. My wife gave it to me. So, and I imagine we might find a few other things to throw in there too. So let's get this thing out of the oven and slice it up and see what we got. All right, let's check out some books first. I got a batch of books from a friend of mine, Bruce Gratton Sr. So Bruce and I talk on email back and forth a little bit, and I actually met him at the Bar Z Bash. So he's a cool cat, retired guy. Anyway, he sent me some books that he picked up somewhere, not sure where, but let's check it out. This one is Manual on Cutting Tools, or Manual on Cutting Metals. But more specifically, this thing is very narrowly focused on single point lathe type tools. So this is a whole, 1.1" thick book on lathe tools. And now, I kind of flipped through here, and there's a lot of information in here, and tool geometries for different materials, cutting speeds, and horsepower to remove metal, things like that. And lots of charts and stuff. Anyway, it's kind of a cool book that's dedicated to single point cutting tools. And let's see if I can read it upside down here. It's to the title page here. Oh, so it's an ASME book, 1939, published. I don't know what edition this one is. I don't know. It looks like it might be the first edition. I'm not sure. Cole Morgan Optical Corp, and this is in Brooklyn, New York. Anyway, cool book, and there's several more. Let's check out the other ones he sent. All right, so this next one here is tooling manual. So this is, I've seen this type of book before. This is kind of practical tips for industry, and these were sold by some of the trade magazines, or given away by the trade magazines. This is American Machinist. So it's kind of a collection of letters and pieces of information that they collect into a digest. And I have a couple of these of different flavors. I can't quite tell what date this is. The only kind of clue is some of the stuff inside, and then this little X53, and that kind of based on some of the stuff that's inside, I think it's around 1953, which would jive with some of the stuff that I see inside. So I've flagged a couple of things. Let's check them out. Oh yeah, this first one here. This is kind of interesting here. This is how to machine the rare metals, and tantalum, titanium, zirconium, and beryllium. So there's a whole big article on machining beryllium, which is kind of interesting. So this is, beryllium has some very strange qualities in the nuclear industry. So it's transparent to certain things and reflective to other things. So it's got some peculiar usage. It's also pretty tricky to machine too. Anyway, they go through how they set this plant up at Y12, which is in Tennessee, I believe. Anyway, they show some of the covers and tool geometries and precautions for dust control for this kind of stuff. So, where they were working a lot of this stuff out, and they actually had some fatalities, not these particular folks, but there were some fatalities from beryllium dust stuff. Anyway, kind of neat. You don't see that every day. Okay, next thing here. Oh, this is pretty cool. So this is some kind of collimator here, X-ray collimator, and there's a little piece of interest there, and they've got a cross section of it, and they kind of describe how they made the thing. And it's neat because it was made on a Monarch EE, and they kind of hand fed the tailstock and did some stuff. And this little intersection right here, there's a 19/1000ths of an inch diameter hole, half a millimeter hole through here, and plus or minus 5/10 on the diameter, I assume. And so it's got a little restriction here. There's some fairly tight tolerances there. But making that's a challenging little job there, and they kind of describe how they did that, and that's kind of cool. Let's see what else we got here. Oh yeah, so this is how I'm helping date this book here, because they're talking about June 51, March 52. As kind of examples, so 53 kind of fits. So anyway, kind of a cool book. Thank you, Bruce. This is great. The American Machinist Tooling Manual. All right, so this next one, this is all you ever wanted to know about turret lathes in one book. So there's probably some turret lathe operators out there that watch, and there's a great little, in fact, I'll pause here. You can pause the video. I'm not going to read this whole thing, but I'll pause it. And this is a great little, if I were 21. Okay, so I'm assuming that you paused, and we're back now. So anyway, it's a great little statement there by the General Motors president. So let's see what other interesting items we found in here. Oh, this is okay. So a lot of people they wonder about how to get accurate holes, right? And if you use good technique, it's fairly straightforward here. So here's a good way to think about it here. So we rough the hole with a drill bit, okay, and then what we do is we true the hole with a boring bar, a single point cutter. So this establishes a true axis for that hole. The drills they wobble and wander a little bit, so the axis of that hole isn't necessarily where you want it to be, but a single point boring tool does. It puts it where you want it to be. And then if you just leave a small amount of stock, if you want to do accurate sizing rapidly, reamers work pretty good for that. Now, if you go straight from a drilled hole to a reamer, all the reamer does is it follows your wobbly hole, right? Well, what it'll do is it'll follow your nice true hole if you clean that up first. So that's just a good technique to keep in mind when you want a hole that's on this rotational axis or in true position. Okay, that's the key. So you want holes in true position. This is a really good way to do it. Even this is associated with lathe work, but this technique is great on the mill too. Okay, all right. So I just wanted to throw that out because it's not something that kind of comes up that often in discussion. What else we got here? I like this one because here's some of us have a little hoist to change heavy chucks, right? Some of us are really strong like Adam, and he just puts them up there with one hand. But for us weenies and weaklings, this is a great one here. It's a strap that has a D-ring here, so it kind of makes a choker, but it's wide. And then it balances the chuck on the center or close to the center of gravity, so you can take it on and off. So anyway, that's why I flagged that one. Then we got a bunch of work holding stuff here. Let's see, why was this one interesting here? I don't remember. Here it is. It's a split ring. So some of you have probably had this problem, right? You have a thin wall tube that's say it's acrylic. okay, and you have, you know, a thin wall, 1/8 wall acrylic tube, right? Well, you grab that in a 3-jaw, and guess what? You get a Mazda rotary engine piston, right? It makes a lobed shape when you try to clamp it. And actually, it's pretty hard to actually clamp with any kind of certainty, right? Well, here's a good way to handle that, is to make a ring that fits around it and fits it closely that's split. Then you clamp that, and then you get basically kind of a collet, a large diameter collet. So that's just a nice trick for holding thin wall stuff and maintaining its shape while you machine it. So anyway, that's why I flagged that one. All right, what else we got? Oh, this is pretty cool too. So this is on a turret lathe. So they've got there's all these guys out there that are just fascinated with spheres and ball turning and all this stuff. They love this shape, this knobby shape here. So here's yet another way to do that. So this has a cam arrangement, and this is on a slide, and this is what transmits, well, as the carriage moves forward, this translates up in an arc here. So yet another way to turn a ball. Okay. All right, so this next one, this is a fairly common book. I actually have an older copy of this, and this is Shop Theory, and this is from the Henry Ford Trade School. Okay, it's kind of a neat book, and this is apparently the 4th edition. And let's see if we can find a date in here somewhere. This one is reading upside down. 42. Yeah, it looks like 42, somewhere in there. Okay, and this is actually a great book. It's just loaded with general information on shop operations, right? Well, there's some cool pictures in here. We're going to go through some of these. We got to go pretty fast here because I got quite a few tags in here. This one I just like because it's a great picture of Johnny Cedar with his hammer raised, ready to do some chipping. And he's appropriately outfitted with his goggles. I just thought it was funny that his name was embroidered on his apron, and they didn't make him anonymous or whatever. Now his pose looks a little staged to me, but he's certainly well equipped. Okay. All right, let's go. Let's keep going here. Like I said, we got to go pretty fast. I got quite a few. Now a lot of guys they ask, how the heck do you use a planer gauge, right? And well, here's one on a big planer, and it's on the bed, and they've set this for a particular height or thickness for a piece, and they're setting the tool. So you loosen that, you drop the tool down on top of the little post, lock that down, you got a good height set, and off you go to the races. And you can set the planer gauge with a micrometer or a height gauge or many other things. So anyway, that was good because it kind of showed one in context, and guys do ask about those. All right, what else we got here? Oh, now this is something you don't see all the time here. And what they have here is, so this is a hob, like a gear hob or something like that. And this little attachment here, it's called a backing off attachment. So what it does is it relieves the teeth of the hob. So the teeth are relieved behind the cutting edge. So it cuts more as the thing rotates. The slide moves back or moves in. One of those. I've never used one, but anyway, it's a backing off attachment, they call it. So it relieves the teeth behind the cutting edge. So it looks like it's an attachment for a lathe here, which is kind of interesting. And it's connected to the rotation of the machine, so it kind of has to be. And then you would probably set it in relation to where your tooth, where your teeth start and finish there. So anyway, not something you see very often. So I just thought it was kind of interesting to show that. All right. What's next here? Oh, okay. This is kind of a dual one here because we have a tool that a viewer sent in, another viewer. But this shows that particular tool in context, okay? So these are end measures here in a little kit. It has a little micrometer and it has some calibrated rods. Well, they sit in this little tray here, and what it allows you to do is make precision movements with the machine. This is pre-DRO days, guys. And very, very precise movements. So Pratt & Whitney kind of developed this, and with these precision end measures. So now what I'm going to do is I'm going to show you the actual tool. This is a set of end measuring gauges. It comes to us from Michael Belak, First Sergeant Michael Belak, retired. And anyway, these belong to his dad, and he sent them into the show, and they're pretty neat. And here they are. And what these are end measures, okay? And let's go back in context here. And these fit in this little tray here, and they actually stop against the machine. And it looks like this one's even more sophisticated. It has a little dial indicator there, so you can make small precision movements within the range of that indicator too, which is kind of neat. But anyway, here they are, and so we have one for each axis, X and Y, and they've got them color-coded, green and red. And then they're different lengths. So that one's 6-inch, and it measures 6-inch, right? So you could actually calibrate micrometers with these if you wanted to. Here's a 1-inch, okay? And I just unwrapped some of them here. And then here's their little support points. And we may have talked about this before, but there's a particular point along the length of this called an airy point that if you support this rod on those points, the ends, there's sag in that rod if you support it. You know, if you hold it in the middle, it bows down. If you hold it out at the ends, it kind of bows up at the ends, right? Well, there's a place called the airy point, A-I-R-Y, I believe is how it's spelled. If you hold it on those particular points, the ends are perpendicular to one another, or are parallel to one another. And is that right? Parallel? Perpendicular, yeah. So that they're basically, so it's good for end measuring things. So the ends are parallel to one another instead of tipped because they're bowed, because the rod's bowed. Now we're talking about real fine fussy stuff, but if you have a long slender rod and you want to support the ends, in a uniform way, there's a spot and there's an equation for figuring out where those places are. So anyway, look it up. It's called airy points, and there's another one called a Bessel point, which is a little bit different, but it's kind of similar thing. So anyway, so these are little micrometers here, and they adjust so you can set precision, odd precision numbers within the range of the set. So Michael, thank you for sending those in, and it just happened to kind of tie in with this image in the book here, which is kind of cool, and kind of made for actually a pretty good little presentation. So anyway, thanks guys. All right, this next book, or this next lot of stuff, comes to us from Sam Robertson, and he's down in Hollywood, California. And he's actually a movie star down there. No, I'm just kidding. Anyway, he sent me some stuff and a book and a few other things, so we'll take a look at it. This is a Jig and Fixture Design, okay? And there's some kind of neat stuff in here. And so Sam points out he sent me a little note here, the difference between jigs and fixtures, right? Jigs are generally, in the classical sense, fixtures used for drilling holes. It's a jig, right? It's a drilling jig. And fixtures are things for holding parts for machining. So just to keep that straight with the world there. So let's take a look here. So this first one I flagged, now it's got a Cincinnati horizontal mill here, but the reason I flagged this was because of this little hand wheel here. And actually I flagged it to show my wife because this is not a stock wheel for this machine here. So they've changed it to increase the leverage or whatever. But it just so happens that there's a small hand wheel on her etching press that's going to have a very similar look to this, a little ship's wheel with curved handles like that. Anyway, I flagged it to show her. I said, hey, there it is. That's what your wheel's going to look like, except it's going to have 5 spokes instead of 4. So anyway, it's kind of neat that way. And you guys will get to see that built and all that. So what else did we flag here? Oh boy, I got to read, huh? Was this for me? Oh, I know what it is. Yeah. I got to remind myself. So I learned a new word from this book, which was kind of neat. I'd never heard this before. So they're talking about classes of fits here, right? Medium fit, snug fit, ringing fit, tight fit, medium force fit, etc. Right? Well, this tight fit, I think it is, yeah, they used a different word that I hadn't heard, and it's called a tunking fit, Tunking fit. And I'd never heard that term applied to what's, basically functionally a metal-to-metal fit. That it's just a slight press to get it together, right? But it's basically full metal-to-metal contact, right? So tunking fit, that's a new word for us there, and I don't quite know the origins of that, but it's when you look it up on the web, it pops up, and it's it's a real deal. So anyway, new word, and it's not made up by me. So all right, what else we got here? Okay, why did I like this here? Oh, this was good because it was some simplified methods for determining stresses this is kind of some shortcut methods, right? Yeah, okay, so you can determine how much stress is on a particular part, if you were to press a pin into here, right? This hub is subjected to stresses, right? And this was just a kind of a quick formula for determining what those stress levels were based on the interference fit and the width of the hub. So it was kind of cool that way. Anyway, Sam, thanks for sending that book. It's pretty crispy, so thanks for sending that book in. I have a newer version of this, but this one's actually pretty good here. And thank you so much for sending that in. Anyway, he sent some other stuff, so let's take a look at that. Well, moving on, he sent a few things in, and you kind of already got a peek at that. He sent a surface grinding wheel, which is in nice shape here. It's a 60 grit aluminum oxide. A ½ inch, that's a useful wheel there. And to go with that, he was such a nice guy. He sent me a hub too, which is a real nice gift. It's great to have a lot of hubs and mount your wheels and be able to leave them on the hubs and just rock and roll. And so Sam, thank you for sending that in. That's a useful grit, and we'll make use of that nice left-hand hub there. So what else? What does this say here? He says, they don't give these things away, and that is true. They do not give them away. All right, so the other thing Sam sent in is he sent these in, and these are kind of mystery tools here. Sort of mystery tools, I would say. So let's open them up here, and I think I know what these are. And these are basically the same, but they're made out of some kind of funky resin or something like that. I don't know. So I don't know if they were just testing out the. It's pretty tough stuff. Maybe they were testing out the molds. These look cast to me. They got that look. And what I think they are is they're heel blocks for toe clamps, similar to these guys here. These are narrower, obviously, but so it gives you a place to increment the heel of your strap clamp up on, so that's what I think these are. And I think that they were testing a mold or something, because it's got a little ejector pin little divot there, or maybe these were cast together or something, I don't know. So anyway, mystery tool, and that's what I think they are, and maybe somebody else has some ideas what those might be. Anyway, Sam, thanks for sending those in, and we'll try to make use of those. All right, this next one is pretty cool here. So I did a little horse trading with the young lads, and I traded some goodies for this oiler here. And these guys certainly know how to bait a trap. I fell in love with this as soon as I saw it, and I was trying to pretend to ignore it, but I didn't do a very good job, I guess. Anyway, it's kind of an automatic drip oiler of some age, and it's just glorious. And it's French, and it's got some maker marks on here, which are kind of neat. Kind of official export maker marks. Some of the design details. I just love this little knob here, you know, with these flared conical finger things. Some plain knurling there, and then some rope knurling here, which is kind of cool. And the glass is quite thick, and then it has a sight glass on the drippy part too, so you can actually see the drips going down. And it's got a pipe thread and a seal. Now the plan, I'm going to try to use this on the etching press, and we'll go pop over there real quick, and I'll show you where I'm thinking about trying to implant this thing. But it's just quite the nice looking piece there. So let's go take a look at the wheel where I'm thinking about putting this. Okay, so you guys have all seen this here. This is the Wobble Drive, right? And so somebody asked actually a long time ago about lubrication for this. Well, it doesn't turn very fast, so it doesn't need a bath of lubrication necessarily, but some lubrication is certainly not going to hurt. Now, but if you have something like this, that certainly becomes a higher priority to get something like this in there, which actually just kind of goes with the whole thing. So I'm thinking about incorporating this in here somehow, and so that it actually lubricates this assembly, and we can drill some additional passages or make some pieces so the oil gets into the right place. And even if it doesn't have oil in it, it certainly looks good, right? It just kind of goes with the Jules Verne theme I got going here with, black and brass, right? Anyway, there's enough clearance here to kind of, squeeze it in there. Your hands are never down in that area. They're always up on the rim. So, it can sit there, and it'll actually rock with the wobble part. Okay, it'll move a little bit, so it'll have a little bit of movement. Anyway, that's my plan, to try to squeeze it in there if I can at some point. So in the build. Anyway.